Question 3.1.2. Determine the nth term of the sequence. All right, so now they want us to be able to determine any term for this sequence. So first, when we hear that, we must think, okay, that means we need to know this formula over here. So this gives you any term in the sequence for a quadratic sequence, where n will be the nth term. But you'll notice we don't have A, B, or C. And I'm going to show you how you find them. So first, there's some sub-steps or sub-formulas that we need to know. For the sequence, the first term can be calculated by saying A plus B plus C. For the second term, it can be calculated by saying 4A plus 2B plus C, and then so on. And you'll notice there's a pattern. That's exactly what we get when we plug in 1 for this formula for n, 2 for n in this formula, and 3. So once we know that the first term is A plus B plus C, the next term is 4A plus 2B plus C, and so on, we can set up some equations. Because if you look at the top, we actually have already found what these values are equal to. And we've even found what this second iteration's difference will be. Namely, it will be 2. So we can set these equations equal to these values and so on in order to determine A, B, and C to set up our general quadratic nth term formula. So the easiest is to begin with the variable that only appears once, and that will be 2A. Then we would move upwards. Because we know A, we can then calculate B. And then once we know A and B, we move upwards and we can calculate C, thus finding all the variables we need. Another important thing to notice is that just like our differences here were found by subtracting or finding the difference between the upper terms, that's exactly what we're doing with these formulas. 4A plus 2B plus C minus A plus B plus C is equal to 3A plus B. 5A plus B minus 3A minus B is equal to 2A. So that's how these formulas come about. I would say the easiest to remember is just remember you begin with A plus B, 3A plus B, and 2A. Then you'll soon be able to see what the next term would be, and then you can start working on finding what A and B and C are. So let's begin. We've already determined that this iteration's difference is equal to 2. So let's solve. I like to make little dots to keep track. Let's solve what A is. A is equal to 1. Okay, great. We have our first variable solved. Now let's move up. So in our difference tree, you could call it, the second iteration's first term was minus 6, or the first difference here was minus 6. So minus 6 must be equal to 3A plus B, but A is equal to 1. So really what we have is 3 plus B. And solving for B, we get minus 9. Great stuff. We have our next B. And lastly, we're going to work up again, just like that, gone up the tree. Minus 1 will be equal to, up the tree, A plus B plus C. A plus B plus C. But A is equal to 1, B is equal to minus 9, so what we have is minus 1, minus 8, plus C, C is equal to 7, if my arithmetic serves me. Yes. And fantastic, we have A, B, and C. So if we look back at our original formula we were trying to find any nth term, it will be Tn for any term will be A, which is 1. So you can just negate, leave that out, not negate it. Don't make it negative. N squared plus B, which was minus 9, plus C, which was 7. So that should be N squared minus 9. And this is our nth term formula. If, for example, they hadn't given us many terms to work with, remember, if you find the first difference, the second iteration's constant difference, you can always work backwards. Look here, you can work backwards over here. If this was a constant difference of plus 2, what would this term have had to have been when plus 2 to get minus 6? This would have to have been minus 8. So all I'm trying to say is that, remember, you can even go even further back if you needed to. But I don't think you would have to. But I'm just trying to show you that you can really work with this tree in order to find terms to make these equations equal to. And don't go parrot learn all of this. All you need to really know is that your general expression you're trying to find looks like this. And you begin with A plus B when n is subbed in for 1, because you're at term 1. Then term 2. And then if you wanted to find the next iteration's difference, you'd say this term minus this term. Exactly what we've done here. And hence solve for A, B, C to get our general term, general formula. And that is the problem solved.